All right, integrated math 2, nets and surface area. Objective, students will be able to use 3D nets, 3D figures and formulas to calculate surface areas. This first term here, this is called a net. That's what a 3D figure would look like if the sides could be unfolded to create one 2D shape. So here's an example of some nets, but only one of them is correct. It says which net could be folded into a pyramid if folds are made along the dotted lines. Here's a situation. You want to think about which one would overlap. So if you folded this triangle up and this triangle up, these two wouldn't overlap, but this one and this one would. So what I'm going to do is I'm just going to highlight the ones that would overlap, and we don't want overlapping. If you were to fold this one up and this one up, these two wouldn't overlap, but then these two would both fold to make this side over here. And so we would have overlapping on this one and this one. So that's not a good net. If we were to fold this one up, we'd have this side of the pyramid, and this would be the opposite side. Then this one would go right here, but then this one would wrap around and overlap with that one. So it would look like that. Kind of give you an idea, so this triangle would end up right here, and that's why the red one would overlap with the opposite side. So that doesn't work. Now, lastly, we have this one over here. If you were to fold right here and then wrap this all the way around, you would have no overlap. And so D is a proper net. But that's not normally how we would draw a net for a pyramid, actually. This is just kind of a way to think about different nets and things you might see. A typical net for a pyramid is you draw the square base, or it could be a rectangular base, or it could be a triangle base, actually, to be a pyramid. And then you just draw the triangle faces on the side. That's typically how you draw a net of a pyramid, just so you know. But I want you to think about how you could draw it as a net so you could figure out the surface area, because now we could say, okay, we got the area of the square, we got the area of these 4 triangles, we find those areas and we add them up. That's how you can find the surface area of a shape. And that brings me to this term. A surface area is the sum of the area of each face of a solid figure. So on this one, we are going to try to draw a net for the right triangular prism shown, and then use that net to calculate the surface area. A little bit going on here. I want to point out that if this far edge is 13, then this edge is also 13. And we have a little right triangle. Well, hopefully you recognize this as one of our triples, and you should say, okay, what does this side have to be if this is a 12 and this is 13? One of our triples that we learned a long time ago was a 5, 12, 13. So I'm very confident this side is 5 centimeters. If you're not sure about that, you could just do Pythagorean theorem. You could say x squared plus 12 squared equals 13 squared. Work it out and you get a 5. All right. This is a prism. It's a little bit different. Here's what I would do. I would start by doing the bottom. Okay. And I think what we're going to have to do is we're going to have to make every dot worth 2, okay? So I'm going to draw the bottom in here, and I think you'll see how to do the rest, but I'll help you out here. So remember, everyone is worth 2, so let's maybe start like right down here. So there's 2 units, 4 units, 6, 8, 10, 12, by 10, right? So I'm going to go up 5. So that's 2 units, 4 units, 6 units, 8 units, 10 units. All right, and there's the bottom. Let's do this edge now. I'll do this in green. And notice that that's 5 by 10. So if I was to go 5 units to the left, because what we're going to do is essentially I'm going to say, like, let's fold this thing down. So if I was to go 5 units to the left, that'd be 2, 4, and then 5 would be like right there. So go right in the middle. And then we have another rectangle, which I guess I'll do in red, and that's this rectangle up top. See this thing? And so if you imagine this thing unfolding this way, you would have a length of 13. So 2, 4, 6, 8, 10, 12, 13. Still by 10, so it just makes an extension of this existing rectangle. And I think it might be a little bit more precise if I drew this all in to like see it instead of just the highlighter, just so you kind of see where this is at. So this is 13, this is 10. This is 12, this is still 10. And then this is 5. And of course this is still 10. All right, so now we have all the rectangular sides. Now we just need to draw these little like triangle wings. So, oops, oh, that's the wrong color. Yeah, see, we got that wing and this wing. So we'll do these ones in yellow. And remember, this like kind of height is 5. So again, imagine like these things just like unfolding on the sides. And here's what they would look like if I was to go up 5, 2, 4, 5, down 5, 2, 4, 5. And then I could just draw this like diagonal here and this diagonal here, which we know this is 5, and this is 5, and this is 13. And this length is 13. And this is a right triangle, and everything else is rectangles. Okay, it says draw the net for the right triangular prism shown. Check, we've done that. And then use that net to calculate the surface area. Okay, so surface area is just the sum of all the spaces. Well, we got a few things going on here to make this pretty easy. Once you draw the net, you might see that really we just have a really big rectangle and then 2 triangles. So I'm just going to mark that I'm going to have a big rectangle plus 2 triangles, just to kind of think about how I'm going to do this. This is not like the official formula or anything. This is just helps me mentally figure out how I'm going to add this all up. And the big rectangle we know is I guess you could call this like a width or a height of 10. And the length is 5 plus 12 plus 13. Well, you could probably do that in your head, but that adds up to 30. Right? 12 and 13 is 25, plus another 5 is 30. So that's that whole rectangle there is 10 by 30. Plus I have 2 triangles, and the area for a triangle is 1/2 base times height. So I have 1/2. We could say the base is this distance here, which we know to be 12. And the height is this distance and this distance, and they're identical, so they're both just 5. That's why I just multiplied them by 2 out here, because I knew they were exactly the same. Well, the beauty here is the 2 and the 1/2, that just cancels each other out. So we don't really have to worry about that. 10 times 30 is 300. And 12 times 5 is 60. And so the answer here is 360. And the units are centimeters, and now we're talking about area, so it's going to be centimeters squared. Boom. So we could use nets like we did on the previous one. We can also use some formulas. And if you look in your notebook, I gave you a whole page of formulas. You could check the table of contents to find where it is in your notebook, but I gave you a whole page of formulas. And what we have to do is just recognize what kind of shape this is first. Well, this is a triangular prism, so we're going to use our prism formula. Okay, I went ahead and copied down the perimeter formula from my formula page. And if you look at the formula page, it also tells you what all these letters represent. But let's just go over it. P means perimeter of the base. H is height, and that height has to do with the height between the 2 bases. So that we talked about this in class, but the base is the most unique shape. And plus 2 times the area of the base, and again, the base is a triangle. So we have to do a little bit of math here to figure everything out. We need to know the perimeter first, and let me just like highlight this so you can see what I'm talking about. Perimeter would be all these distances added up. And clearly we don't know this third distance. So we're gonna have to do a little bit of math to figure that out. It's a right triangle. And so we could just go off to the side here and we say, well, we know that 8 squared plus 9 squared has to equal this hypotenuse squared. I'll call it L for now. You could call it anything you want. I didn't want to call it H because I have an H here that reads something else. So 8 squared is 64, 9 squared is 81. 64 plus 81 makes 145. And basically I'm going to have to take the square root of both of these. Now that's not a perfect square, so I'm just going to write that that's square root 145. I'm just going to leave it exactly like that. No need to simplify it or anything for now because I'm plugging it into a big old formula anyway. So what would I write as the perimeter? Well, we have to add up all those sides, right? So the perimeter we could say is 8 plus 9 is 17 plus the square root of 145. I'm going to leave it like that in exact terms for now because I'll plug in my calculator later and I'll let that be more specific. Okay, next I need the height, and the height is this distance here, or this distance here, or this distance they already told us over here of 5. So I'm going to go ahead and just say, okay, I know the height is 5. plus 2 times the area of the base. All right. Well, this is a triangle. So to get the area of the base, I need the triangle formula. Well, the area of a triangle, if you remember, is 1/2 base times height, where base and height are perpendicular to each other. So these could be your base and your height. So I'm going to just go ahead and plug that right in my formula. It's 1/2 8 times 9. All right, I have all the pieces in my formula. I'm ready to go. The only thing I would do, you don't have to do this part, but this will often happen when you have triangles. See how I have a 2 times 1/2? These are all just being multiplied together, but 2 times 1/2 just cancels out to be a 1. So really that's irrelevant. We don't have to plug those both into our calculator. So we're ready to go. We don't have any units here, so we're just gonna say it's units squared, and we're ready to just plug this whole thing into your calculator exactly how it's written here, using parentheses and everything, and I think we'll be ready to go. All right, when I plug this all into my calculator, I get 217.2, I'll say 21. When they don't say, I like to round to the nearest hundredth, just as an estimate, units squared. Now, a couple things I do want to point out here. When you go to type this into your calculator, I didn't think about this part. Your calculator most likely is going to put a parenthesis right there. So you have to tell it when you're done with the square roots. You're actually going to need 2 sets of parentheses for this first expression, times by 5 plus 8 times 9. So you might have messed up with that other parenthesis. That could make things, if you don't put in 2 parentheses there, you could get a different number. All right, let's move on to the next one. Okay, practice 3. Wesson wants to have an ottoman reupholstered. This is an ottoman. Reupholstered means you put new fabric on it. Find the surface area that will be reupholstered. So the thing you got to keep in mind is they're not going to reupholster the bottom. So normally, this is just what we call a rectangular prism, right? Above we have a triangular prism. This is a rectangular prism. So the basic formula is the same, that the surface area equals perimeter times height plus 2 times the base area, except for in this situation, we don't need to reupholster the bottom. So there's not 2 bases. Like here, there was a top and a bottom. Here, there's only a top. So I can basically just cross off that 2 and make that a 1. Okay? Let's make it a little bit cleaner. 1. There's only 1 base that I'm adding up. So all the math here, the basic idea is the same. What's the perimeter? Well, the perimeter is just all these sides added up. All the sides added up, okay? So, yeah, I have a 2.5 here and a 3 here, but I have another 2.5 over here and another 3 here. So 5.5 plus 5.5 is 11. I'll highlight that in yellow. And then I need the height. And I know that's the height right there because it's simply the height. So the height of the shape. So I'm going to put a 1.5 right there. Plus basically 1 base area. The base area is just a rectangle, right? So I'm just going to do 2.5 times 3. All right, and we can use a calculator for this, which I would like to do just to, because you got decimals involved. You don't have to, but just makes your life easier. So when I plug this in the calculator, I get 16.5. I mean, you could kind of do that in your head because 1.5 of 11 would be 11 plus half of 11. So 11 plus 5.5 is 16.5. 2.5 times 3 is 7.5. Add those together, you get 24 feet. And these are all in feet, so your area is going to be square feet. There you go. All right, let's go to example number 4. And this one, it's a little tricky. So an office has recycling barrels for cans and paper. The barrels are cylindrical. Cylindrical just means it looks like a cylinder, with cardboard sides and plastic lids and bases. Each barrel is 3 feet tall and the diameter is 30 inches. How many square feet of cardboard is used to make each barrel? Okay, before we do anything, what I want you to recognize is that's feet. Our answer is supposed to be in square feet, but that is in inches. We have to have everything be in the same unit in order to move forward. So the first thing we need to do is say, okay, I want everything to be in feet. But right now I only have inches. What do I know about feet and inches? Well, I know that 1 foot is 12 inches, and I have 30 inches, and I want to multiply 30 times 1 foot over 12 inches so that my inches cancel out. And now I have 30 over 12 feet. Well, 30 over 12 reduces to 2.5 feet. So I don't want to think of that as 30 inches. I want to think of that as 2.5 feet. Now everything is in feet, see? It's got to all be in the same unit for it to actually work and make sense. So now let's talk about how we're going to do this formula. We know that it's a cylinder. And the black here is going to be the cardboard. And the red is the plastic. Okay. The surface area formula for a cylinder is 2 pi r squared plus 2 pi rh. And if you look at the diagram on the formula sheet, you can kind of see why this is. This 2 pi r squared are these two circles on the top and bottom. This is the sides if you were to unfold it. And if you to get a better explanation of that, look at the formula sheet and it shows you. But if you were to unroll that side, it would make a rectangle. That rectangle would have a width of 2 pi r, the circumference, and a height of h. So in this situation, since all we're doing is finding the cardboard part, which they tell us the barrel is associated with cardboard sides and plastic lids and bases, and they just want to know the square feet of cardboard, we really only care about this part. So what do we know? Well, let's go for it. Surface area in this situation would just be 2 times pi times the radius times the height. Well, we now know that the radius is 2.5 feet. Therefore, the diameter is 2.5 feet. Therefore, the radius would be half of that. So that would be 1.25 feet. And the height, we already know the height. It says each barrel is 3 feet tall. So the height is just 3. And that's all in feet now. So we know that our answer is going to be in square feet. Now we can actually do this math. Well, 2 times 1.25 is just 2.5. 2.5 times 3 is 7.5. So I would just write the answer as 7.5 pi square feet. You could also plug this into a calculator to get a decimal answer, but this we like this. This is exact because pi is an irrational number. It goes on and on forever, so we'd rather just leave it like that. But 7.5 pi is approximately 23.56 square feet. So like I said, we prefer it in exact terms. Just leave the pi symbol right there. Call it a day. That's a lot easier to deal with. But this would be it in decimal form. Okay, I've done a few examples here. Remember, I'm referring back to that formula sheet in your notes, so you want to keep that handy. So I want you to try practice 4A on your own. It says find the surface area of the cylinder with a height of 6.6 and a radius of 8.3. So this one, you're just finding the entire surface area, so you're going to use that whole equation, not just part of it. Go ahead, give that a shot, and check back when you're ready to check your work. Okay, I just used the formula for the surface area of a cylinder, and I just plugged in my dimensions for radius and height here. Whenever I plug in a value, I like to use parentheses. And from here, since you already have decimals in your answer, and you got a pi here, I would just go ahead and plug it all in the calculator. I mean, there's a way to get an exact answer here, but you're going to be left with some nasty decimals anyway. So I wouldn't really worry too much about getting it exact in this context. So plug it all in your calculator like this, and you should get something around 777.04. Okay, let's talk about practice 4B. This one says find the radius of the base of a right cylinder if the surface area is 128 pi centimeters and the height is 12 centimeters. I'm going to start you off on this one. So again, we're talking about surface area of a cylinder, so I'm going to use the formula for a cylinder, or surface area formula for a cylinder. And now I'm going to plug in what I know, but this time it's a little bit different because this time they actually told me the surface area. We know the answer. What we're trying to find is the radius. They told me the height, so I can plug that in. I'm trying to solve for r. Interesting. So let's plug in what we know. We know that this is 128 pi. 2 pi r squared plus 2 pi r times a height of 12. And just want to highlight that so you see where everything's coming from. Well, we need to solve for r. Well, what I would do first is I notice a pi here, a pi here, a pi here. I notice a 2 here, a 2 here, and this is an even number. So what I would actually do, just to make my life easier, is I would just divide everything by 2 pi. I think it might make the problem a lot simpler to deal with. So if I do that, 128 divided by 2 is 64. This would leave me with r squared plus 12r. And now we have what starts to look like a quadratic. Remember, we did quadratics last semester, and you can kind of see the application of some reasons why we might need to solve for a quadratic. So to solve a quadratic, you want to get it equal to 0. So I would subtract 64 from both sides. And so I have 0 equals r squared plus 12r minus 64. Now at this point, you can use the quadratic formula. You may remember that one. Or you might be able to factor. So I always like to see if I could factor first. So is there anything that multiplies up to negative 64 but adds up to 12? Let you think about that for a little bit and see if you can go from here. Have fun. And you can unpause the video when you're ready to check your work. Okay, well, I did the star method here, and I found that negative 4 times 16 is negative 64, and negative 4 plus 16 is positive 12. So a couple things about that. I could write this in factored form. I could write it as r minus 4 times r plus 16. Or I could just go ahead and say, you know what? I know my answers are going to be the exact opposite values of this. So my answers are 4 and negative 16. And let's go back to what we were talking about originally, right? Isn't this the radius of a cylinder? Well, negative 16 doesn't really make sense in that context, right? So really, the only answer that actually is valid here is 4. So what would the answer be? The radius of the cylinder, everything's in centimeters. The answer is the radius is 4 centimeters. Boom, boom, boom. All right, let's go to the next page. All right, last example here. The roof of a birdhouse is a regular hexagonal pyramid. The base of the pyramid has 4 sides and the slant height is 12 inches. Hexagonal pyramid, what does that mean? Well, it means we have a hexagon as a base, and then we have 6 triangular sides. Try to do that side there as the faces. And it says the base of the pyramid has sides that are 4 inches. So these are all 4 inches. And we could go ahead and just like say these are all the same. And the slant height is 12 inches. So slant height, this might be something we talked a little bit about in class, but slant height is the diagonal height that's like perpendicular to this base edge. So that's 12 inches. And I believe on this one, what they're asking for is the lateral area. It doesn't actually say, huh? Yeah, so let's go ahead and find the lateral area. When they ask for lateral area, what they're saying is they want all the area of all the sides, but they don't want the area of the base. Which is good because the area of a hexagon could get a little complicated. There is a way to do it. There's formulas for it. There's some things to do. You can chop it into triangles and find one triangle and times it by 6. But all we really have to do is find this face of this triangle. And since there's 6 faces, multiply by 2. Another way of doing it is the lateral area formula, which is simply 1/2 perimeter times the slant height. So that's actually pretty easy to do if you think about it, because we know that there are 6 sides, so the perimeter is simply 6 times those 4 inches. So I'm going to put 24 here. And we know that the slant height, they told us, is 12. So this isn't so bad. 1/2 times 24 times 12. Well, half of 24 is just 12. So really this is just 12 times 12. So we could say it's 144 square inches. Again, this is just lateral area. If they wanted surface area, I'd have to also find the area of this base. But that's possible. Maybe if you want to try a real challenge, you can see if you can figure out what the area of that base is. You know, in fact, if you do it, put it in the summary response and see if I'll tell you if you got it right or wrong. Okay, summary. On the formula page, there are a lot of new terms. Take some time to look at the pictures and determine what some of the new terms mean. What are some of the terms I'm talking about? Perimeter, slant height, base area, height, all those types of things. Write a definition for perimeter of the base, area of the base, and slant height in your own words. And by the way, we have letters for all of these. So when you see the word P, that's perimeter of the base. When you see the word B, that's area of the base. And when you see L, that's slant height. Okay, so those are our different terms that are new that you need to learn. Maybe you could come up with some definitions for those. All right, thanks guys. See you guys on the next video.